My name is William Adibero Emmanuel. I'm a master's student like you people, studying the Faculty of Education Department large course called FED 804. From the past record, I could see that many students are having problems related to this course. And even in the present class, as master students under 2021-22 sets, alongside with 22-23 sets, some are having problems with this course in the class. And I've been able to look at topics that could help students to learn better and come out good in this course. So I'll be treating at first problem related to probability, set theory conditions, entering into permutation and combination. That you cannot determine the outcome until you have performed the experiment. And when we are looking at random experiment, what used to happen is that you pick at random what is called a sample, because there is a sample that has the quality of all other element that is present in a what? In a set related to probability. The next thing we must understand, sample space. What is sample space? The sample space is the what? Is the number of possible outcome in a random experiment or in a random sampling. Why lastly, events. Event is the part of the point in the world, in the random sampling. So these things I've itemized, I've highlighted. They are things you will see in past question that you must understand, so that when you want to pick your answer, you know that event is the what? Is the part point in the word, in the random sampling. Why the random sampling is the word? Is the experiment that you must perform, and the outcome of it is what you get to be your what? Your elements of that set. And probability is the what? Is the possible outcome that we can actually have. Having understood this, we can now go into question proper. Like I wrote on the board, find the probability that the score is greater than 4 when a dice is thrown once. Probability check different thing. In terms of experiment, we can use a die, we can use a coin, we can use pack of card, but strictly working with our material is mostly related to dice and coin. So I'll be working with this question. A die has 6 faces, and we can number it to the word 1, 2, 3, 4, 5, and 6. The question now asks, it says, what find the probability that the score is greater than 4? Greater than 4 means it will be more than 4, and that shows that it will be what? 5, 6. So only 5 and 6 is greater than 4, and since 5 and 6 is greater than 4, meaning that we are having 2 out of 6. So probability of what? Greater than 4 will now be what? Equal to 2 out of 6. And when we cut 2 by 6, we have it to the word to be 1/3 as the answer. That's the first stage of the question that I was able to coin out of our past question related to this. The next question. 2 coins tossed at the same time. What is the probability of what? Showing the same face. What's the probability? At least 1 head. What's the probability of obtaining more head than tail? How do we solve this kind of this kind of question. The easiest way to solve is by what? Is by drawing a table. And that table is that since it is what? It is two coins with big toes. I'll be having head, I'll be having tail. I'll be having head, I'll be having tail, representing the what? The vertical, the horizontal. I can now relate head, tail, tail, head, and tail. I am concerned with this inside, which I am drawing a circle. Is where I'm concerned. And with this, if the question shape showing the same face, which one has the same face? Head and head, they are the same face. Tail and tail, they are the same face. But tail and head are not the same face. Head and tail are not the same face. So I can see that I have one, I have two. So I have 2 out of what? Out of 4. So probability of same face, is equal to what? 2 out of 4. And if I cut 2 by 4, I'll be having 1/2, which half is the answer. So the answer to this first question is 1/2. The second question, it says at least one head. If I check, I'm still making use of this table I've drawn. At least one head. I have what? 2 heads here. I have 1 head here. I have 1 head here. So at least means not less than 1, but I can have more than 1. At least means not less than 1, but I can have more than 1. And I have head here, I have head here, I have head here. So because of that, it will be the probability of what? At least a head will be what? Will be equal to 3/4, because there is, in spite of the fact that there are 2 heads here, I have 1 head there, I have 1 head here, I have 1 head, so it is 3/4. So the answer here is 3/4. And obtaining more head than tail, meaning that I have head more than tail. If I check here, having head more than tail, it is this one, I have head, no tail, isn't it? But this one, I have head and have tail, so there is no more than. I have tail, I have head, it's no more than. And I have tail. Since it is no more than, it is only this I have. So my answer, probability of more head will be what? Than tail will be equal to 1/4 as my answer. That's as regards to that sum related to what? Since we have understood how to solve problem when a coin is tossed twice, or a coin or 2 coins tossed at the same time, which is 2. Now let us learn about a coin either thrown twice, tossed thrice, or 3 coins tossed at the same time. Like I wrote on the board, I said tossing 3 coins at the same. The probability of showing the same face is what? Probability of obtaining more tail than head is what? How do we get this done? Let's take like this. 1. If it is 1 coin, toss once, it will be head and tail. If it is tossed twice, we said we will draw a table, we make it head, tail on the horizontal and the vertical head, tail, so that we can now connect. Head to head will become head. Head to tail will become head, tail. Tail to head will become tail, head. And tail to tail will become tail, tail. So inside is what we are making use of. So we have 4 elements that make up the probability, and here we have 2. Now if it is 3, what do? We draw another table. we on the horizontal, we pick all the elements inside. H, head, tail, head, and tail. And we have on the vertical tail and head. So head to head become head. Head to head tail become head, tail. And head to tail head become head, tail, head. And head to tail become head, tail. While tail to head become tail, head. And tail to what? Head tail become tail, tail. And tail to tail become tail, head. And tail to tail become what? Tail. Now, this is what we are using. It is what is within. We are also using, like the way we did in 2. We didn't use anything outside, either horizontal or vertical, but within. Meaning, if we check, let's count 1, 2, 3, 4, 5, 6, 7, 8. We have 8 items. Now, it says showing the same face. Which one has the same face? Showing the same face means that the 3 items must be the same thing. And if we check from what we have, this is head. So this one is the same. That's number 1. Head, tail, head. Head, tail is not. Head, tail, head is not. Head, tail is not. Using a coin. Probability has different area of approach. Now we see another one related to numerical sampling in terms of probability. I wrote a question on the board. I say, a 2-digit number is formed using digits of 2, 3, 4, 6, when no digits may be repeated. We are forming 2-digit number out of 4-digit number when no one is repeated. The question now says, write down the elements of the sample space. If you remember, we said the sample space is the what? Is the set of the possible outcome in a random experiment. I want us to still bear in mind, because these are part of the question we see in our objective questions. Now, it says, write the elements. What are the elements? The elements are what we can get out of it. Let's start with the A as elements. And this, the 2 says, compute the word. The B says, compute the probability that the number so form is what? Even, at least 60, and 3, a prime number. Let's start with the A part. What are the elements that we can get? Remember that the number is what? Is 2, 3, 4, and 6. And it said we should form 2-digit number. How do you form that? Look at it. What the question is saying, because it's part of our objective question we see in exam, if you check your past question. So you form 2-digit number saying 2, add 3 to the back, first one. 2, put 4 to the back, the second one. 2, put 6 at the back. You have made use of 2. The next one you can use is what? 3, put 2 at the back. 3, put 4 at the back. And 3, put 6 at the back. That's it. You have exhausted that of 3. 4, put 2 at the back. 4, put 3 at the back. And 4, put 6 at the back. You have exhausted that of 4. The 6 own, put 2 at the back. 6, put 3 at the back. And 6, put 4 at the back. And that is the last number. You have been able to form what the question says, write down the elements of the sample. So these are the elements of the sample that we have gotten. Let's see the B part. The B says, even number. What are even number from our elementary? Even number are number that are divisible by 2. Number that ends with what? 0, 2, 4, 6, 8. So let's see. These end with 4, this end with 6, this end with 2, this end with 4, this end with 6, this end with 2, this end with 6, this end with 2, this end with 4. So how many can we now count out? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have even number, they are 9. The probability of what? The number that we have. Compute the probability of 9. And how many is the total number? We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have total of 12. So probability of 12 will be 9 over 12. And 9 over 12, if we cut down, 3 in 9 is 3. 3 in 12 is 4. So it is 3 over 4 as the answer. Now let's look at that is Roman figure 1. Roman figure 2. At least 60. Anything at least means not less than 60. So this first one we call it probability of what? Probability of even. I'm doing the probability of not what? At least 60. So it can be greater than 60 or equal to 60. This is the sign, greater than 60 or equal to 60. And if I have on the board, under the elements, I'm able to write which one is 60. No one. But we have greater than 60. And greater than 60 is what? 62, 63, 64. Which is 3 out of what? Out of the 12 items. And if I cut 3 here, 1. 3 in 12 is 4. So we call 1 over 4 as the answer. And the last thing, which is the 3, Roman figure 3, which says a prime number. Probability of what? Of prime number. We know prime numbers. Prime numbers, according to elementary learning, are numbers that can be divided by itself and one alone. Prime number, they always have 2 factors. So among these numbers, which are the ones that you cannot divide it by only, you can only divide it by itself, meaning that number, and one alone. And if you look at it critically, you can see that you cannot divide 23 with any other number than 23 and 1. So this is the first one you can pick. 24 is an even, so it can be divided even. We have picked out all the even number before, so we don't need to bother ourselves. Let's just go the one we did not pick that is even. We are left with 43 and 63 again. So we ask, 43, is it a prime number or an even number or odd number? Because it is odd, and it is also a prime number, because 43 can only be divided by itself and one alone. And if you see, 63 also can only divide by itself and one alone. So because of that, we pick this also. But 63 is not a what? It's not a prime number, because 63 is divisible by 3. That is to tell us that it is not what? And even, it's not a prime number. But 43 cannot be divided by any other number. So because of that, we can see that 23 and what? And 43 are the only 2 numbers that are prime. And because they are 2, so they are 2 out of 12. And 2 out of 12, if you divide, 2 here is 1. And 2 here is 6. So it is 1/6 as the final answer. I'm going to the set aspect of the probability. What is a set? A set is a collection of items having identical relationship. So I can have a particular thing having some sub-things inside as a set. Let me use an example. A mathematical set. All the instruments that are present in it, the ruler, the set square, they are all elements of sets of a what? A mathematical set. I'll be making use of A and B as a what? As 2 different sets. If I have A and I have B, A is a set, B is a set. Between A and B can only be known through using set notations. What do we call set notations? We have signs that we use. For example, I have intersection. If I want to relate A and B as 2 different sets intersecting, I will write A intersection B enclosed, meaning that there is a relationship between A and what? B. The intersection means and. So, what does A intersection B means? A intersection B means whatever I can see in A, I can also see in B. I'm going to give elements to A and B for us to understand. For example, on the board, if I have A, B, C as elements of A, and I have what? C, D, E as elements of B. A intersection B as the cardinality of A intersection B will give me what? That what can I see in A that I can also see in B? And if we look at from what we have, I have C in A, I have also C in what? In B. That shows that A intersection B, what I can see in A and B is what? Is C. That's the answer. So, by the word of our learning, we say they are what? They are mutually related or mutually dependent. Because why? They are an element that is related to both of them. Now, I want to use the union. If I have the cardinality A union B, by set theory, I have not entered into the usage in probability. By set theory, what does it mean? It means A or B. A or B in the sense that what can I see in A, I can also see in B. That is common to the both of them. A or B. What you have in A or you have in B. You want to see it. And what are the things I have in A or B? It will be what? A, I have B, I have C, and since I have C, I have C, so I don't need to write C again. I have D, and I have E. So these are all the elements of A union B. From our previous learning, using a coin that is tossed thrice, or tossing 3 coins at the same time, we have understood that we can deduce a table like this. And this table will be our sample space as S. The sample space is what? H, 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 T, H, T, H, H, T, T, meaning that head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. And tail, tail, tail. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements in the word, in the sample space. But we have said, let A be what? Element of the same face when a coin is what? Is thrown thrice. Which element have element of the same face? We see that head, head, head is all true. And this tail, tail, tail is all true. But other ones, they have head and tail. So the one of the same face simply means the element in A with the word will be head, 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 and what? And tail, tail, tail. Why the B? We said element more head than tail. Where do we have more head than tail? We can see from the first. If we are using the sample space, we have head all through. So head is more than tail here. 1. Head is more than tail here. We have head, head, tail. Head is more than tail here. We have head, tail, head. We check. Tail is more than head. But here, head is more than tail. We have tail, head, head. Is there any other one? No, no, no. So these are all the elements that we have in words. We have in A and B. Now, let's look by probability related to what we are talking about. Probability of A intersection B bisect theory is said to be, what are the elements we can see? Because intersection means hand. A and B. What are the elements we can see in A? We can also see in B. We have head, tail. But we cannot see. We can see what? We can see head in what? In B. And we cannot see any other thing. So since this is what? Head. It simply means that the only element that exists in the two is what? Is head. Which means that they are what? They are interdependent. As we can have it. They are what? They are interdependent by the theory of sets.